அது என்ன இது ஃபார்மட் வந்துட்டு வேர்டு அந்த மாதிரி வச்சு பண்ண முடியுமா?
கூகுள் ஸ்லைட்ஸ்
அப்படியா?
சைட்ல என்ன சார்
வெற்றி சார்
35
ஃபார்ம் ஃபில் பண்ணா எல்லாத்துக்கும் கூகுள் ஸ்லைட்ஸ் தான் எதுவுமே இருக்காது. அதுக்கு ஃபர்ஸ்ட் நீங்க ஆட் பண்ணலாம். சர்டிஃபிகேட் இன்னும் ஒரு ஆட் பண்ணி அதுல ஒரு டெம்ப்ளேட்ல நீங்க அதை போட்டா அப்படி பண்ணணும். அதுக்கு ஃபர்ஸ்ட் நேமு காலேஜ் நம்பர் சர்டிஃபிகேட்ல எடுத்துட்டு ஆகணும். அதை அந்த ஆர்டர்ல வச்சு அதை அந்த சர்டிஃபிகேட்ல அதுக்கேற்ற மாதிரி போட்டு.
அப்படியா?
சார் குட் ஆஃப்டர்நூன் சார்.
சார் குட் ஆஃப்டர்நூன் சார். வணக்கம், எப்படி இருக்கீங்க
சார்? நல்லா இருக்கு சார். ஆல் யூ ப்ளஸ் சார். ஸ்கிரீன் ஷேரிங் செக் பண்ணிடலாமா சார்?
செக் பண்ணிடலாம். ஒரு நிமிஷம் சார். நீங்க இது கோஹோஸ்ட் மாத்திட்டீங்களா சார்?
நோ, மாத்திட்டு இருக்கேன் சார். ஒரே நிமிஷம்.
ஓகே சார். ஓகே சார்.
மாத்தியாச்சு சார். சார் உங்க ஸ்கிரீன் ஷேர் ஸ்டாப் பண்ணுங்க.
சார் தெரியுதுங்களா சார்? ஓகே இல்ல சார்?
சார் பெர்ஃபெக்ட் சார். பெர்ஃபெக்ட். நீங்க
சார் நான் எப்பவுமே பெர்ஃபெக்ட்டா எல்லாம் ரெடி பண்ணி வச்சிருவேன் சார். நீங்க வந்தீங்கன்னா டக்கு நம்ம ஆரம்பிச்சிடலாம் சார். ஒன்றும் பிரச்சனை இல்லை.
ஓகே சார். சார் நீங்க இப்போ 2 o'clock வரைக்கும் ஃப்ரீ ஆயிட்டீங்க சார். 2 o'clock மறுபடியும்
ஓகே சார். ஒன்றும் பிரச்சனை இல்லை. இன்னொரு 10 நிமிஷம் தானே சார்? ஸ்கிரீன் ஸ்டாப் ஷேர் பண்ணட்டுமா?
ஓகே.
ஓகே சார். ரைட் சார்.
வாங்க தலைவர். சார் ஃபீட்பேக் லிங்க் நீங்க ஆட் பண்ற. Sir, chief guest, sir. Sir, 2 minutes, sir. Sir,
Oh, no
just
problem,
2
sir.
minutes. Let the other participant to
No
join,
problem,
sir.
sir. No problem, sir. I will wait. No issues, sir.
Thank you, sir.
Okay, okay, sir.
Stop video.
Sir, chief guest, sir.
Sir, yes, sir.
Sir, we'll start, sir.
Okay, okay, sir. Yes, sir.
Okay, sir. இப்போ நீங்க ஸ்லைடு ஷேர் பண்ணிடுங்க. Then I will start officially.
Okay, sir. Okay, sir. Okay, sir. Sir, share agudilla sir?
Yes, sir. Yes, sir. Yes, sir.
Okay, sir. Right, sir.
Yes, sir. Yes, sir. You are visible.
Okay, okay, sir. Okay, sir.
Program 2 1.5 present here and this 6 days international level faculty development program with the topic of futuristic research in mechanical engineering. And on behalf of SRM University, Ramapuram campus and Department of Mechanical Engineering, I welcome our Honorable Chairman, Co-Chairman Sir, and Chief Director and Director Sir, and our beloved Dean ENT, Dr. Murali Krishna Sir, and our beloved Vice Principal Academics, Vice Principal Admin, and our beloved VP Academics and Head of the Department, Dr. G. Prabhakaran Sir, convener of this program. And I welcome all other department heads and faculty members and each one of the participants of today's program. I welcome you all. And my special welcome to Dr. L. Ganesh Babu Sir. In spite of his busy schedule, he accepted our invitation to present his speech on today's program. I welcome you, sir. And I request one of our coordinator, Yes, Ganesh, sir, to elaborate about today's speaker, Dr. L. Ganesh Babu, sir.
Thank you, sir. It's my pleasure to introduce today's. Am I audible? It's my pleasure to introduce our today's chief guest, Dr. L. Ganesh Babu, sir. Sir is currently working and is a assistant professor in the Department of Mechatronics Engineering at this International University, Iraq. Sir has completed his ME Mechatronics Engineering at the Madras Institute of Technology, Worldwide. Sir is having more than 15 years of teaching experience and also has 8 years of research experience. Then Sir has published more than 30 papers in websites and more than 70 papers in papers. And Sir is having 5 patents and published 5 books and many number of national and international conference presentations are given. Thank you, sir.
Thank you, Ganesh, sir, for chief guest introduction. So I request our chief guest, sir, today's session is yours, sir, please.
Sir, good afternoon, everyone, sir. First of all, I thank to SRM Institute of Science and Technology giving me the opportunity. And I thank Dr. G. Prabhakaran, sir, convener of the program. And I thank Dr. V. Thanigavelan, sir, co-convener of the program. Sir, thank you for giving me this opportunity, sir. And I thank coordinator, Mr. M.P. Vetri and Mr. M.P. Krishnan and Mr. S. Ganeshan for this thing, sir. Thank you very much for opportunities giving me, sir. Sir, shall I start the thing, sir?
Sir, definitely, sir. Welcome, sir.
Okay, sir. Sir, my topic is related to modern mechatronic system. So modern mechatronic systems in automation technology. So in this, we see about the contents, about first introduction and what is mechatronics, then mechatronics from mechanical system, then modern mechatronics from mechatronic systems. So these are the 4 things we will see, sir. First, in this abstract, we'll see about the what are the things we did via mechatronics, how can we will making the systems, recent achievements in cyber physical systems with the help of artificial intelligence and the design of mechatronics. And this presentation provides some physically insighted into the modern mechatronic smart automation and cyber physical systems and smart domain from the cloud platforms. And then we can see about the various cycles, productions of the MMSA. First, we will see about what is mechatronics. This mechatronics is the combination of mechanical and electronic system and software. The name mechanism, we can take mecha, and then electronics, we can take tronics. So joined together, they say as mechatronics. How this word was came means, the first by Mr. Tetsuro Morova, a sensor designer, Japanese country, Yakashwa, introduced this mechatronics in 1969, sir. So he, the man who keep the word called mechatronics. So then this mechatronic system, okay, how the mechatronics is formation? It was the combination of all departments, like multidisciplinary engineering, we can say, from mechanical engineering, electronics engineering, computer engineering, and control engineering, and design engineering systems. So with this only, we form this mechatronic systems. With this mechatronics, we are using the applications from various areas, sir, in automotive, aerospace, medical, material processing, manufacturing, and defense system, xerography, and consumer products. These are the major places we are using this mechatronics as a applications. And this is the basic element of mechatronic system. Mechatronic system always it works in two category: open loop category and closed loop category. So maximum we'll go with the closed loop categories nowadays. So in this, we will say first we are giving digital actuators and analog actuator to the mechanical systems. Then it will give the output of digital sensors and analog sensors, it will come. And then it will goes to microprocessor systems to control the unit, and it will automatically give the feedback, and we will go for the systems closed loop. Again, continuous process will be there, sir. First, we see elements in systems, we can see sensors. The sensors is sensing products conditions to the mechanical system, providing the input to microprocessor or microcontroller. So from the digital control architecture, we can say provides the signals to the actuators. After that, the actuators means it activates the mechanical system to bring into the required conditions to control the units. So this is the key elements of mechatronic systems. First, in mechanical system, what are the key elements we can say? In this, they have a system model and dynamic response. First one we see about actuators. In this actuators, what are the materials we can use as actuators? So solenoid valves, voice coil, then DC motors, then stepper motors, and servo motors, and hydraulic pneumatic system. These are the actuators to operate the mechanical system. And then we go for these sensors. Okay, in this sensor, we can say switches, potentiometer, photoelectricity, digital encoders, then strain gauge, thermocouple, then accelerometers and MEMS. These are the major systems to give the mechanical system to the input signal conditions. In this input signal, we can use direct circuits, filters, amplifiers, AD, DD, that means analog to digital converter, digital to analog converters, digital to digital converters we can use. Then we can control with the help of this, we can go for digital control architectures. In this digital control architectures, we are using logic circuits, microcontrollers, PLCs, program controllers, communication, control algorithms, logic and algorithms, sequencing and timing, everything it will comes under the digital control architecture. It will controls and it gives the output to the output signal condition and interfacing systems. In this, we can use D2A, DD amplifiers, PWM means pulse width modulations, power transistors and power operational amplifiers we can use. With this, our output is, it's okay, means it will go to graphical displays. If the output is not okay, we want to get more outputs, then you can give to the mechanical system to operate the system again. So we want to see the outputs, we can go with LEDs, LCDs, then CRT, digital display units. We can use the systems in this system, sir. And this is the elements in mechatronic system. Okay. For example, I'm using electromechanical systems. In the electromechanical systems, what are the materials, what are the tools I am using, what are the sensors, what are the actuators I'm using? I'm just here I'm placing for you. In that PLC I used, then PIC controller I used, DC motor, digital encoders, then part to vary the amplifiers, and voltage regulators, all these conditions to drive these systems for using electromechanical operations. So these are the MEMS sensor, the sensing 5 things to humans. How can we make a robot in this system? So for the brain, we can use RF communication. That means oscillators and tuners and switches to filters to give the radio frequency communications. And for the smell, we can give the gas sensor and electronic noses for the voice the system to alcohols. And for focusing, we can give autofocus sensors to operate the focusing devices. For the taste, we can give humanoid sensors to make the sensing systems. Then for speech recognition, you can give the micro speakers and the mics to how can connecting with the mechatronics application. For moving the systems, we can give the pressure sensor, and for touching the and to withdraw and taking the system, we can use the force and touch sensors and haptic sensor. These kind of sensors we can use. And for fluid systems, so joining and moving, these things we can use micro pumps and biochips to operate the humanoids. And for audio signal, we can give the ultrasonics and microphones to operate the humanoid robots to access the human capability systems. So for body balancing, we can give the internal systems like a microcontroller or pick controller system we can keep, and it will body balancing how to adapt the mechatronics human robots to the conditions. So in this evaluation of mechatronic system, we have totally like 4 kind of evaluations, sir. Okay, that is a primary level, secondary level, tertiary level, and country modem levels. These are the 4 levels. So I will explain you one by one in the next slides. First, we'll see about the primary level mechatronic system, sir. In this primary mechatronics level mechatronic system, the sensors and actuators integrated with the electric signal and moving the mechanical actuation to the basic control level. This is the first level of primary mechatronic system. For this, we can give the example of electrical controlled fluid valves. And the second level of mechatronic systems, we can give microelectronics into electrical control devices. We can use this as a cassette players. And third tertiary level mechatronic system, what they use, they bring the smart systems to operate the system via control strategies, including some microelectronics, microprocessor, PIC controller, and microcontroller, and other applications we can use as integrated circuits in the name of ASI, we will say. So for this, the best example we can give DVD players, CD drives, automatic washing machine, CD drives, and we have etc. So next, this quantitary that we say the 4th level of mechatronics, modern mechatronics, now we are using that mechatronics. This level is controlled by including the artificial intelligence techniques. In this artificial intelligence techniques, we can use the fault detection and isolation method to make the system, and then using in the overall this field. So we can use artificial networks and the fuzzy logic technologies to operate these modern systems. So next, industrial automation. How the mechatronics fields, they are in the industrial automation system. For this one, first you are using the automation control system and information to technology to reduce the production of goods and services. With the help of this automation, they invented accelerator after General Motors invented to PLCs, that means program logic controllers, in 1986, along with the controllers. After that, they introduced more advanced technologies one by one. After PLC comes, they introduced PID, propagation integrated derivative control system, to operate the mechatronics elements. And then they bring SCADA, superior control and data orchestration. After that, they bring distribution control systems, enterprise planning. Like this, they bring one by one. Then in 2011, the German company, they introduced the high-tech program level to modify the entire manufacturing cycle to 4 IR sensor to the 4th industrial revolution systems. So different types of automation tools exist and we are using in the day-to-day life in modern mechatronic system. Okay, sir. First, artificial neural networks, then distributed control system, then human machine interfaces, then supervised controller and data acquisitions, program logic controllers, then programmable automated controllers, and instrumentation, motion controllers, robotics. These are now the technology they are using for the tools to operate the mechatronics system. Then control system. So what is control system? Control system performing the following functions. Always the control system to make the particular values of the output of the system. In this some condition, we can satisfy the particular sequence by even giving the corresponding output into the input. So the blue line indicates the actual response. Red line indicates the desired response. What are the inputs you are giving? It will changes depends on the output response, sir. With this response, we can make the systems. So first we'll see open loop control system. What is open loop control system? In this open loop control system, what are the inputs we are giving to flow the control law and plant to the output directly? We cannot able to, once if you give the work, it will be finished. We cannot able to redo it. For this purpose, depends on the output on input, but controlling the action is totally depends on the changes in the output. And no feedback is used to control the most independent determining and the what signal to the ITS. So we can say plant equal to mathematical model of input amplifier plus actuators plus physical systems. So in this, we can give the input system reference, desired input or set point we can fix. The output was measured by the what the input we are giving, like that it will come. So control loss, this can be used the mathematical modeling of controllers. For this, the best examples we can give switch on and switch off system. Okay, when you switch on the light, the lamp filament will be glow and the glass will be on. The same we can fill the water tank. Okay, when you open the valve, the water automatically it will fill only. We have to close manually. This is open loop control system. But now we see about the advantages and disadvantages of the open loop control systems. First, we'll see about the advantages. It was simple construction, costs also very low. And the implementing output is difficult to measure. We cannot able to measure how much output we are getting that one. So next disadvantages of this one is actually the actuators did what supposed to do it. The inaccurate system will be there and unable to sense the environmental changes or disturbance of this open loop systems. But now we'll see about the closed loop system. This is the closed loop system. Controlling action will depend on the changes in the output. Once if you give the input, it will go to the erroric system and it go to the control law and it go to the plant and it will go to the output. Then after finishing the output, again it will check giving the feedback to the control system and it will go again. Each and every time your input value you are giving the output continuously, we can change and we can change the values. For the best example, we can show automatic control system using in our tank machines. When you switch on the motor, automatically what the water level will increase means it will automatically stop. When you using the via outflow, when you open the valve, completely the water comes drain, automatically the motor was on. This is the best example for automation closed loop system. So for this also we have disadvantages and advantages. So first advantages we'll say accuracy, since the control modification and manipulation, actually the signal should be error in the system will be 0. Self-correcting will be there and some sensing environmental and disturbance in the system we can use. And same thing for disadvantages, we can complicate it to design and cost wise it will be little more. And unstable, since due to feedback system tries to correct the errors, it will be create some magical systems. So next we see about the mechatronics from mechanical systems. So this mechatronics does not indicate a new revolutionary technologies. It is philosophical approaches in which machines, electronics and IT are frog to the signal way to the produce the enhanced product of the systems. In this process, we can use semiconductor system. The semiconductor sensors and actuators called electromechanical. We say MEMS, electromechanical systems. So in this device, we can change the mechatronic systems disaster in 21st century by merging silicon-based microelectronic with micro machining technology. So then this technology MS products will advanced control system currently available in number of industry smart products in many domains. And we can use all these powerful and complicated systems are controlled by the microcontrollers, on which intelligent software running along with the external devices, such as sensors and actuators may interfere with the microcontrollers and it will activate. So in this micro electromechanical systems, technology consists of microelectronic elements, actuators, sensors, and mechanical structures built onto a suitable, which is usually using silicon. These components made up of 1 to 100 micrometers in size. In this size, their components will be there and they can use it. The benefit of using MEMS, we can use for speed, size, system integration, and power consumption all in one chip. And this technology is efficiently used in the almost every field, such as automotive, electronics, medicine, communication, defense, and manufacturing industries. All places they are using this one. For example, we can see in airbags, intelligent tires, then disk drive heads. These kind of places, this MEMS technology they are using. We can say about the MEMS component. We have different kind of MEMS component. Microelectronics, micro sensor, micro actuators, microstructures. These are the major 4 components of MEMS. These are the more components of the MEMS. So we'll see one by one. What is microelectronics? This is the brain that receives the processor and make the decision. Data come from microsensors. And microsensor constantly gathering the data from environment and process the data to microelectronic to process to the, can monitor the thermal, mechanical, biological, and chemical optics and magnetic readings. So then uses of micro actuators. The micro actuator acts as a trigger to activate the external device, and microelectronics will tell micro actuators to activate the device. After this system process over, then we can go for the microstructures. Microstructures, extremely small structures built onto a surface of a chip and built into the silicon of the MEMS, and we can operate the systems. So basic principles of the actions. So in this, measuring parameters, and it will goes to use useful signal via conversation devices. So in this measuring parameters, they can say displacement, temperature, pressure, strain gauge, like that we have a lot of sensors. And in useful signal, voltage, current, capacitance, like that they are using. So in this, sensor is a device that when exposed to physical phenomenon and temperature, displacement, force, etc., to produce the professional outputs with the help of signals. So then we can say that signal, electric signal, mechanical or magnificate or electromagnetic, like that we can use the signals. Then we can say about the transducer is a device that converts one form of energy signal into another form of energy signal. So first we'll see about the strain gauge. Here the strain gauge, we already know about it. This is the best various resistance to conduct a semiconductor when subject to the mechanical stress. This strain gauge, the electrical resistance of a wire having a length L across the section A and drive the resistance of rho. So R equal to rho L by A. When the wire is stressed along to R, undergoes the changes, and the passing small amount of current through which wire, it will help us measure to voltage the chances. The sensing element of the strain gauge is made up of copper, nickel alloy. The alloy fall as the rate resistance change to proportional to the strain with the constant system. Then this strain gauge, we can make this. Then we can make this strain gauge for the various systems, for one side to another. For this one, tension causes resistance increased, bonded the strain gauge. This another resistance measured between 2 points. Compression causes the resistance increases, and the gauge sensitive of later force, it will be bonded the strain gauge systems. For best example, we can say about the electric power steering examples we can use. In this electric power strain gauge, when we strain gauge, we will sit the electric steering column, torque sensor, and reduce the gears, and rack and pinion mechanism and motor sensor. We are using electric motors. So when we use the power amplifier circuit and then motor control and strain functions, the sensor will be activate and evaluating the systems. So with this, we can operate the system automatic to the car examples. So here, mechanical system versus mechatronic system. So how can we say strong, large, and heavy compared to mechanical mechatronic system? Reliable and reliable design is difficult and costly. But when it comes to mechatronics, light system, easily reprogramming, less space consuming, and easy replacement, and complex to common man. So we can use this, the combination of mechanical systems and mechatronic system. So applications of mechatronic system, medical field. So we can use automobile, home application, automotive production plants like tool monitoring system, automated guided vehicles, conveyor system, bottle filling plants. In medical systems, for example, in nowadays, in some other countries, the robots they are using and then they are operating the human bodies in some foreign countries. So in automobiles, every automation, the robot can fix the cars and electrics, everything they fix for the doors, everything without mens, they are using the mechatronics applications there. So in this advanced mechatronic systems for mechatronics, we can use currently replacing a new requirements on the technologies used to support current and product service productions. The underlying prescribed to the transfer of functionality from the mechanical domains, from electronics to the information domains, and how we maintain the mechatronic systems also. So here, device to device, or along with the pre to machines to pre taking mechatronics device with the sharing knowledges. More importantly, we used services and wisdom services through this platform, and we content the depends on the data needs to function the more desired way for these MEM systems. And then further developments of technology and responsible to increase the customer delivery, these things and all, we can use this mechatronic system application. The main things included intelligent information and communication technologies, such as we are using in these conditions, big data analysis, data mining and machine learning, cloud platforms, WSN wireless sensor networks, cyber physical domains, and more importantly, interconnection of various IoTs and MS systems. So first we'll see about the big data. Okay, in this big data is collections of data to huge in volume, yet to grow the official times. And with the larger size and complement of the traditional data management tools, and we can use the sufficient systems. And big data is also a data, but with a huge size. Recently, advance in cyber physical domains and platforms, the big data and data analysis have enabled to develop a open architecture with the intelligence sharing and servicing to the web of thinking. Web of things. Good platform can accept a large volume of big data in high dimension that they forms the general and smart systems to wisdom employing to the intelligent data. So this is the big data's normal, how can it will operate. So we can use the big data via volume, size of data, and velocity, variety, veracity, value, so vocabularies, venue, variability, validity. So all the consist with this one, the big data should be used and we can adopt with the mechatronic systems. So next, data and data mining and machine learning. In this, data mining is also known as discovery process in the field of science to find the property of data sets. And machine learning is a technical to develop the algorithm for processing the data delivery result to its users. And programs that can learn experience that make predictions. Both data mining and machine learning are area that have been inspired by each other to many things in common to end the different level of systems. So in this data mining, perform the humans on criteria to data set with the aim to find the interesting pattern between the items in the data set. Data mining used techniques developed by machine learning for predicting the outcomes of the systems. So machine learning we can use. How can we use the machine learning systems? So in this, we can use the via training test, supervised and unsupervised system to go to the future extraction idea. So in this, the machine learning algorithm, it will divide into two groups of things. One is grouping of objects and another predictive model. After that, it will come to the annotated data, and the data will be operating to once to another systems. And then third one, we'll see about the cloud storage. This cloud storage is referred to access the over internet and the software system. This database runs to the server and cloud server to locate in the data centers in the all over the world. And cloud platforms is advantages on enormous storages, heavy computational global coordination and wide area connectivities to use the quick information and serve this centric service and its resourcing pooling. The main cloud platform providing including the Amazon and EC2, Alibaba, then Microsoft. So like this, Google serving the public networks, also connecting to the business world to connect the platforms, infrastructure as a service and the platform as a service and software as a service. Also, we can use this cloud storages. This wireless sensor network. This wireless sensor network configured and interface less wireless network to monitoring the physical or environmental condition, such as temperatures, sound, vibrations, to make the systems. We are using the wireless sensor network techniques. And then variably between users and networks, this wireless sensor technique transferring the data one place to another places to retrieve the required information from the network, injecting the queries. This wireless sensor contains hundreds and thousands of sensor nodes. This sensor node communicate among themselves using radio signal. A wireless sensor node is equipped with these sensing and computer devices and radio transducers and power components. So this is the wireless sensor node communication, how we can use. The sensor node can be communicated directly without decoded thanks to single hop and communicate with the sync. So using the communication with multi-hop and passing the information of the neighbor systems. Here we can say how can the communication link will be working with the sync and external network we see in the picture. Framework of modern mechatronics. This is the modern mechatronics framework, how it will be adopted. For example, monitoring and controlling first, it will be there. In this location, independently display, update and upgrade, new service integration, actuation, failure propagation and diagnosis. From that, it will send to all over the places. Okay. Then it will goes to sensing or sensor electronics, then it will go to environmental system, then electronics, and electronics goes to information and fusion intelligence, then it comes to smart domain and mechanism, then it goes to information fusions and intelligence, then it will comes to, so like that wireless communication will change to one place to another. Like this, we have the problem of the systems and we can manufacturing and making the mechatronic systems. So in this modern smart automation system, we can say majority of mechatronics have a sufficient resource from the processing of big data with the respective advantages process and monitoring tools. And this evaluation of the industrial IoT or 4IR create the responsibility of connecting computers automated to the remote monitoring and rapid response of the events. The data collected by the sensor in a raw in a large volume. These data need to store, process, and analyze to the extract and from the information, and we can storage and data analysis tools provided by the cloud platform. The outcome derived from the raw data collected by the sensor can be used by an application as a service, such as information service and wisdom as a service. So then we can use the future intelligence system with this automatic supervision and fault diagnostics of these components. One mechatronic system may monitoring by the health of the mechatronic systems. Advanced intelligence diagnostic and prognosis application without human inventions are required in order to face the manipulations such as software failures in MMSSA. So framework of MMSSA. In this framework, first we can go with the production systems. Okay, from the production, it will directly goes to the reducing the designing, run timing changes and enhancement, smart device health monitoring, reducing the cost, feedback of the promotion. Then we can use the sensors from the WSN and IoT, sensors, process, accurate and products and analysis data, input and output in the fault diagnostic and the health management, real-time performance analysis. So other side, we can use the input and output and big data analysis and making the cloud storages. We can make the systems by the production of plants. So this is the major explanation for this framework. So the main components design the platform automated by MMSSA along with the intelligence performance and customers vendors. So then the production plant which supports the QoS in the main aspect. So then along with the capability of the cloud and edge performs open up the possibilities for dynamic learning through the autonomous feedback. Then we can cross-linking between the stakeholders during the product life cycles are designed, and MMSs are designed to utilize the valuable of WASS and INSS in the first instance rather than the embarrassing of the more sensors. Then we can determine how to accurate of the, it can be fused with the other information gathered from the local sensors, and with this the real-time data collection and control process can be operated. The main reasons of connecting these edges platform from the cloud forms while maintaining the local independent monitoring and control abilities also we can do with these systems. So then detecting the problems and fixing the lifetimes of MMS and carrying the new products and making the 4 improved systems in order to cause the similar fault to learn from the expensive of the product currently used. Assume that a customer is using an intelligent autonomous blind system working based on the changing the daylight and weather condition along with the super performance. It needs various sensors to able to detect the current weather and the daylight and conditions to work on the desired systems. So in this, the system obtains this service wisdom as from the smart city domain in the cloud platform, how much it's supposed to open or close windows without knowing the current outdoor conditions. Then the user can monitor and control the systems using location independent abilities to edge and the cloud platforms. In this, still a pending problem with the system is depicted to the vendors using in the intelligent prognosis embedded systems in the using of cloud platforms. The problem may be fixed in the cyber physical platforms online, and some of them can be fixed off by the engineers on the sites itself. In particularly hardware problems, patches, upgrades and updates for the system performed by the vendors in the cloud platform itself. But MMSs maybe still have sensor to obtain the required from is not or cannot be created in the smart domains. Why we need adopted the MMSA system? Companies will be able to track and monitoring the performance of their smart products in real time and will be able to fix their problems on the most of the switch online. The efficiency of the smart products will increase through effective products life management, and the structure of this product will be less complex and constituted less error prone. The customization will be easier. The cost will be decreases insufficient with the less number of sensor with less complex structure using a service network. Customer satisfaction will be increased within smoothly environmental within 24/7 working products we can use for this MMS system. This modern mechatronics smart automation, we have main advantages: remote monitoring with automations, fault diagnostics, replacing human operators in tasks that involves hard physical or mono work, replacing humans in a task done in dangerous environment, like for example, we can say fire, space, volcanoes, nuclear facilities, underwater. Then performance tasks that beyond the human capability of size, weight, speed, envelopes, etc. Economic improvement we can use with this. And disadvantage of this things was technology limits, unpredictable development cost, and maybe we are giving high initialization cost. These are the major disadvantages of MMSA. So applications of these systems for using in car manufacturing, we can see this one. So in this, how the robots working there, and how they're automatically fixing the car body parts, everything, and they're checking all the things in this, we can see. Then oil and gas industries. Some oil and gas industries areas, we cannot able to go and work in under the more constructions. For that field, we can use this robotic application and automation things to make this oil industries. Medical field. Already I said about medical field, they are using now robot systems to operating the things. For example, we can say laser cutting operations and minute operations and all we can do in this medical fields using this MMS technologies. Then marine industries. Ship also we can use. In the ship, what happened? It's going in the middle of the sea. We cannot able to give the signals. For that, what they will do with the help of satellite, and they connected with wireless sensor networks, and they connect two things, and they get all internet facilities and other things we can use in the maritime industries. So related to this, I'm coming to the conclusion of this MMS. Mechatronics thinking as the lead of cyber product systems and the conscious smart domain, which are now transforming MS into MMSA in smart platforms. And the need for high productive density based on the continuous charging market and customer demand within customizations products. And we can use the reproduction quantities and reduce the concept of market lead times and lifetime optimization of the products as resulted in the shifted approaches manufacturing areas, and particularly through the availability of the smart domains also. Against the background in this studied analysis transforming into the respect to the recent advantages in 4IA products, cyber physical smart domains and platforms, communication technologies we can use for the fundamental features of MMSA sectors. And the user-driven development for a new and innovative MMS will rapidly replace the market current products. This MMSAs in the distributed cloud approaches the edge, as well as 4Is will have the significant economic impact on by transforming many enterprises from digital to intelligent business, enabling new business model, improving the efficiency and increasing the employee customers engagement within the automation systems. And the anticipated that the development of the efficiency and the robust models in the MMS will be further advanced futures, innovative products based on this MMS concept presented in the treatise resulting in industrial systems and re-revelations of the system. Sir, thank you. Do you have any questions?
Thank you, sir. Participants, if you have any queries, now you can clarify your doubts with our chief guest. Participants, please, if you have any queries, you can discuss with our chief guest right now.
Good afternoon to all. Hello.
Yes, sir. Yes, sir. Please, sir.
Yes, sir. I'm audible.
Yes, sir. Audible. Please.
Okay. Myself, Tashi. Sir, my question is that automation, as we are talking about that automation is very useful, as explained. And first of all, I want to say that presentation is very nice, well presented data. So, in the case of industries, small scale industries, automation, how can help out for the high production? Because small scale industries, there are small unit, small product they have to make. So automation, basically, my question is that because for automation, we need a very initial investment is very high for any automation. So how
Yes, sir. Yes, sir. Yes, sir. Sir, if you want to go for automation industries, the investment was very high, sir. I accept that. But small scale industries also, we can get some bank loans from the banks. We can get it and we can manufacture and we can do the things also from the small scale for small scale industries, sir. So actually, if you are, we are engineers, we are working in the professors. If any small scale industries persons, they will come and ask, I need some automation machines. with the help of our Indian manufacturing instruments, we can design automation machines, sir.
Okay. So we
So
because
with
yeah,
our
please
students,
continue.
we can do the design of machine, and then we can give for the small scale industries also, sir.
So it could be their project work like this. So because this type of project not least as required only 6 months, but it's a continuous process. Sir. If you get some problem from the industry for the automation, so it will require more time. Not is a
No, sir.
matter of 6
Sir,
months.
sir, each and every automation industries, okay, sir, if you want to implement means we have good engineers.
Yeah.
Okay, and they have very talented engineers also there. With the help of that engineers, we can easily repair the instrument and we can give for them, sir. That is no issues. Actually, in previous days, repairing the machine was very difficult, but nowadays not like that, sir. We have more internet facilities. With that internet facility, the design engineer, he can sit from one place and he can tell you to design, and your students also, he can design the machinery, sir. No issues in that.
Okay, sir. Thank you, sir. And thanks for your nice presentation. Very well explained, sir. Very well explained.
Thank you very much. Thank you, sir.
Okay.
So participants, even you can feed your feedbacks in chat box also. It will be useful for us for making documentation. Thank you, Prabhakaran sir and Kamrumaran sir. Anybody else? Anybody wants to clarify your doubts? Still, our chief guest is online. It's another doubts. You can clarify your doubts with our chief guest. Participants, any doubts? So I request one of our coordinator, Mr. Krishna, for vote of time.
My audience, sir.
Yes, sir, please.
Thank you, sir. Thank you, sir. So, sir, really thank you, sir. Yes, sir. I have to thank you personally for the topic, sir, which is very helpful for the subject which I'm actually handling. Thank you, sir. I got a few informations. Thanks for the content, sir. So I have to go for our formal vote of thanks. Good evening to all present here for the international FDP on futuristic research in mechanical engineering. On behalf of the Department of Mechanical Engineering, Institute of Science and Technology, Ramapuram campus, Chennai, I'm very much glad to have this opportunity to thank all you at this international event. First of all, I thank the resource person of this session, Dr. L. Ganesh Babu, for giving an excellent presentation on modern mechatronics and smart automation. Sir has explained in a meticulous way the details of the smart automation and the smart industries. Thank you very much, sir. I take the opportunity to thank our honorable chairman, co-chairman, respected director, respected dean, ENT, respected vice principal academics, and the vice principal admin. And finally, I take the opportunity to thank all the participants and the faculty members of the various colleges. And last but not least, I take the opportunity to thank our coordinators and the organizations for this wonderful program. Thank you. Thank you very much. The participants, we have posted the feedback form. So please give us the feedback form.
So thank you, Ganesh Babu, sir. Thanks for
Thank you very much, sir.
Thank
sir. Thanks, sir. Romman Nandi, sir.
Thank you, sir.
Thanks for giving me the opportunity, and I thank your management also for the opportunity, sir. Thank you,
sir. Thank you, sir.
Nice, sir. Thank you very much.
See you all the best.
Nice, sir. Thank you.
So participants, please kindly go for a feedback and attendance form. It is mandatory for securing your certificate. Ah, sorry.